All right, today we're jumping into a super cool project that does something your phone's weather app just can't. We're talking about a do-it-yourself lightning detector that gives you live super local storm data right where you are and, get this, sends it all straight to the internet.
I mean, really think about that. Your weather app gives you a general forecast for your whole area. But what about that specific storm cloud that's bubbling up just a couple of miles away? Getting an instant heads-up alert could be the difference between, say, getting your expensive electronics unplugged in time or just making sure everyone's safely inside.
And that's exactly what this project delivers. This isn't some off-the-shelf blinking box you stick on a desk. Nope. This is a smart, connected device that you actually build yourself. It feels the storm coming and immediately pushes all that juicy data to a custom web app that you can check from literally anywhere in the world. Okay, so how in the world does a little DIY device pull something this cool off? Well, it all starts with a few key pieces of hardware that have to work together perfectly. Let's break it down. So the absolute heart of the operation is this sensor, the AS3935. You gotta think of it as the device's ears. But these aren't just any ears. They're specifically tuned to listen for that unique electromagnetic crackle that lightning makes. Even if it's 40 kilometers away, it's a total specialist. Now, all that information from the ears has to go somewhere, right? And that's where the Arduino Nano ESP32 comes in. This little board is the brain of the whole operation. It takes the raw signal from the sensor, figures out if it's actually lightning, calculates how far away it is, and, this is the crucial part, it handles the Wi-Fi connection to get that data out to the world. Of course, you need some local alerts too, right? You want to know what's happening even if your phone's in the other room. That's where the buzzer and the RGB LED come in. They're basically the device's voice. You get a sharp beep to tell you a strike was just detected, and the light can shift from a calm green to a, pay attention, yellow, and then an urgent red as the storm gets closer. It's an immediate warning you just can't miss. Okay, so having the right hardware, that's step one. But the real magic, the secret sauce, is in the software. That's what makes this thing so smart about filtering out all the electronic noise that's constantly around us. And this is a huge deal. The biggest challenge is telling real lightning apart from just electrical interference. Think about it. Your microwave, a light switch, your garage door opener, they all create these little electromagnetic hiccups. The code cleverly uses a function called mask disturber to identify these false alarms, it calls them disturbers, and just ignores them. It's trained to only react to the very specific signature of a real lightning strike. This is absolutely key to making it reliable. And to make it even more reliable, it actually has two different modes you can use. By default, it's in outdoor mode, so it's on high alert, listening for storms way off in the distance. But if you bring it inside, you can flip it over to indoor mode. This just dials back the sensitivity a bit so that all the electronics in your house don't keep setting it off. It means you can pretty much use it anywhere. All right, now we get to the feature that really takes this project to the next level, its connection to the internet. This is what turns a simple local detector into your own personal remote weather monitoring station. So when a lightning strike is confirmed, how does it talk to the web app? It's actually pretty simple. It packages up all the important info into a simple text format called JSON. I mean, this line of code you're seeing here, that's literally the message it's getting ready to send. It's just bundling up the distance, the strike count, and everything else into one neat little package. And what's actually in that package? Well, all the good stuff. You've got the type of event, the distance to the storm, how many strikes it's counted so far, which mode it's in, indoor or outdoor, and even whether or not the buzzer on the device is turned on. It's a full status update every single time a strike is detected. Now hold on, because this is where it gets really powerful. The device doesn't just talk, it also listens. Every few seconds, it pings a specific URL to see if you've changed any settings from the web app. This means you could be miles away from home, see a storm brewing on your phone, and remotely switch the device from indoor to outdoor mode. Or maybe turn the buzzer off so it doesn't wake anyone up. That's full remote control right from your pocket. So when you put all of these pieces together, what do you really have? Well, you've got your very own piece of the Internet of Things. A custom-built tool that gives you critical data that literally nobody else has. Let's just run through the advantages here because they're pretty clear. You get hyperlocal, real-time lightning data that's way more accurate for your house than any regional forecast. You have complete remote monitoring and control from a simple web app. Its smart filtering and different sensitivity modes make it incredibly reliable. And maybe best of all, the whole thing is open source. Any electronics hobbyist can build one, even just on a simple breadboard, and get it up and running.
You know, when the device is just sitting there, quietly on duty, there's a simple message on its little screen. It just says, "Waiting for lightning." It's a simple phrase, but it just perfectly captures that feeling of anticipation. It's just standing guard, connected and watching, just waiting for the storm.
What's so amazing about a project like this is that it shows just how easy it's become to take a sensor, hook it up to a brain, and give it a voice on the internet. So it leaves you with a question, right? Now that a personal lightning detector is something you can actually build, what other part of your world could you connect and monitor? What other data is just out there, waiting for you to collect it? If you want all the details on how to build this exact project, make sure you visit the source at chemcool.co.za.